Go.
Okay, crude oil. Crude oil is formed over thousands, well not thousands, millions of years by dead sea creatures. From dead sea creatures that get buried under the sea, and after millions of years we take them up and we burn them. And crude oil is just a mixture of hydrocarbons. Hydrocarbons, common question, are made up of hydrogen and carbon only, and that's the key thing. You must say that it's only hydrogen and carbon. Now these mixtures of hydrocarbons are called alkanes. Now when we say it's a mixture of hydrocarbons, it's like a bag of sweets. A bag of sweets is still a bag of sweets, even though you've got Haribos in there, you've got Maltesers, you've got all kinds of stuff, it's still sweets. This mixture of hydrocarbons is made up of all these things called alkanes. Now the thing about them is they all end in ane. So you've got methane, ethane, propane. So if it ends in ane, it's an alkane. Now its general formula is CnH2n plus 2. What that means is if you've got one carbon, so then the N is 1, that would be C. You would put a 1 there, but you don't need to, because the mere fact you've put the letter there suggests that there's one of them. H, 2 times 1 is 2, plus 2 is 4. With ethane, that's got 2 carbons, 2 is the N, so it's H, 2 times N, 2 times 2 is 2, plus 2 is 6, and so it goes on like that. Now then, the reason we can separate this crude oil into different hydrocarbons is because they all have different boiling points. And that is the key bit of information. They will always say, why is it we're able to separate crude oil? They have different boiling points. So all the different sweets, all the different alkanes are all different sizes with different boiling points. And how do we do that? Well, we put them into the fractionating column. I can never spell column. Is that's 1L, column, okay. And this is a process called fractional distillation. So how do we separate crude oil? By fractional distillation. And there's this tower that they'll often show you, you'd never be expected to draw it. And what happens is the crude oil is pumped in down the bottom. And this is where all the heat is. And what happens is the crude oil, it vaporizes and it rises up, and then they all condense at different temperatures. So these are the key bits. Vaporize up, and then they condense. Now it's really, really hot down the bottom here, so you've got large boiling points. And these are your really, really thick, long chain hydrocarbons. So long chains down the bottom. At the top, it's cooler. And this is where you get your gases. So you get your small chains with low boiling points. And they are mostly gases, okay? And in the middle, you've got your liquids. Okay, so what we find is those ones with the long chains at the bottom, they are what we call, they are viscous. Love that word, viscous, okay? That means they're gloopy, that means they are really, really stodgy, a bit like custard but thicker, okay? Whereas at the top, they're not viscous at all, and they are really light and runny, and they flow really, really easy. Also, if you wanted to set fire to those really, really long chains, it would be really difficult. So these are less flammable at the bottom, and at the top they are more flammable, so they are more volatile. That means they set on fire easier. Is that flammable? 1M or 2? 2. Flammable. Okay, so the reason these have got really, really high boiling points is because they've got long chains. Now these long chains, what they do, they're like spaghetti, okay, and they all cross over with each other, and in between these chains you get weak intermolecular forces. Now, it's the weak intermolecular forces that give them the high boiling point. There is far more of them in a long chain than there is in the short chains. So they have got far fewer, therefore they are easier to get to boiling point. And the next thing we do is actually, we've got all these different things, all very useful. We've got gases at the top, we've got our fuels like petrol and diesel here, and then we've got really, really long chains like bitumen down at the bottom, and that's what we use to tar our roads with. Now, some of them are useful, some of them aren't, and that's when we go on to cracking.